Thank you. Most of the Good morning. This is Kumar, Assistant Professor, Chair Departments from the Privileged Engineering. My subject is applied physics. Today we will discuss photoelectric effects. Now, photoelectric effect on the formal mathematics. So this is photoelectric effect from the year one is quantum mechanics. You know the difference between the glass plane and say quantum. Classical mechanics explain about the emotional or objective bodies, observable are the observable instruments like star, planets, and also macroscopic particles. Macroscopic particles moving with non-relativistic states like magnetic distribution of electromagnetic radiation is discontinued. That is the classical. But the some deficiency of classical mechanics which are it could not take region of atomic dimension. Like it could not express about the non-relativistic particles like electron, proton, neutrons, according to classical. And also they could not explain about the large number of phenomena like quantum effect, photoelectric effect, Raman effect. And what is the quantum mechanics? The quantum mechanics explain about the microscopic particles like electron, protons, neutrons. The energy distribution of the electromagnetic radiation is discrete that according to the quantum mechanics. What is the discrete? The different states having the same energy that is called the discrete. I think the energy between the two levels is same. Nothing the energy level with energy of the distribution is of the electromagnetic radiation is nothing but from h mu to h mu x. The energy difference between the two levels is same. That is one over here one h mu to h mu the difference is that. That is a different state having the same energy. That is based on the quantum mechanics. Now, what is the topic? Is photoelectric effect. The photoelectric effect introduce the urge based on the electromagnetic radiation. The ultraviolet electromagnetic radiation all on the zinc plate. They laterally experimentally verified photoelectric effect is multiplied based on the light having a suitable frequency falling on the alkali metals. And then the Millicom got a Nobel Prize on the phenomenon of photoelectric effect in 1923. That is the difference between the classical mechanics, quantum mechanics, and what is the photoelectric effect. We will discuss photoelectric effect. Then what is the way we will explain sequentially with representation. What is the first? What is the photoelectric effect? Then experimental study of the photoelectric effect in the Einsteins. According to based on the Einstein, experimentally verified the photoelectric effect is Millicom. Millicom explained the photoelectric effect on the base of the Einstein. That is an experimentally proved, and then the Millicom got the Nobel Prize on the photoelectric effect. Today, afterwards, we discuss basic variable of parameter in the photoelectric experiment. Then the photoelectric effect from the metal, the electron is emitted. The electron, how much having the kinetic energy, and how much electron emitted from the metal depending on the intensity of the incident radiation, potential difference between the plate A and plate B, and frequency of the incident radiation, and the photon levels. We use to the different photon metal based on the photon metal. The electron number of electron is emitted, and the electron having the some kinetic energy. This character is based on the electron emitted from the metal, how much the electron emitted, and what electron how much having the kinetic energy. What is the four characteristics? One is the potential difference between the plate A and plate B. Second one, intensity of the incident radiation. Third one, frequency of incident radiation on the different photometers. Then the law of photoelectric emissions and also photoelectric cell and application of the photoelectric cell. We discuss one by one. First is what is the definition of the photoelectric effect, experimental study of the photoelectric emission according to the Einstein, and variable of the photoelectric current experimentally, that is the characteristic of the intensity of the incident radiation, potential difference, frequency of the incident radiation, and then law of the photoelectric, different laws of the photoelectric emission. And then we discuss about the photoelectric cell. And then what is the application of the photoelectric cell? We discuss one by one. What is the definition of the photoelectric effect? What is the photo? Nothing but a light. Electric, nothing but electron or electric current. When the light falling on the metal, the electron is emitted from the metal, and the electron passing through the circuit, that is called the electric or electric current. That is now the definition of the photoelectric effect. When the electrons are emitted from the matter, and whenever light of suitable wavelength or frequency fall on the surface, the electron is emitted. That is the definition of the photoelectric effect. What is the definition? The photoelectric effect is a phenomena in which electrons are emitted from the matter whenever the light of suitable wavelength or frequency falling on the surface. Here we take the matter, metals, non-metals, or other. We use to the metal, non-metals, solid, liquid, gases. Here the light of the suitable wavelength taking the beam of the photons. When the light having the some frequency incident on the incident radiation having the suitable frequency, and the light incident on the metal, from the metal the electron is emitted. That is called the photo. When the electron is emitted from the metal, that is called the electron photoelectric. This phenomenon is called the photoelectric effect. What is the light incident on the metal, the light having the suitable frequency incident on the metal, from the metal the electron is emitted. That electron passing through the circuit. When the electron passing through the circuit having the some electric current. That is called the photoelectric current, and this phenomena is called the photoelectric effect. What is the definition? When light of suitable frequency falling on the surface of the metal surface, the electron emitted from the metal surface take place. When the electron emitted from the metal, that is the photoelectric current, and this phenomenon is called the photoelectric effect. Okay, understood definition. When the light having suitable frequency incident on the metal, from the metal the electron is emitted, and that electron passing through the circuit. When the electron passing through the circuit having the some current due to the electron, that is called the photoelectric effect. Now definition of the photoelectric. We use to the matter different metals. Alkali metals, other metals, or non-metals. Suppose alkali metal used to the light is visible light, and suppose used to the metals used to the near ultraviolet light, used to the non-metal, you light is extreme ultraviolet light. Depending on the matter, used to the different lights. Suppose alkali metals, the alkali metals is sodium, potassium, lithium, cesium, zinc. That's when we take the alkali metal, the metal take the alkali metals. At the time, the light having the superphylic frequency, nothing but the light is visible light. The visible light falling on the alkali metal, and alkali metal is emitted the electrons, and that electron passing through the circuit. When the electron passing through the circuit, nothing but the circuit having the some electric current, and this phenomenon is called a photoelectric current. Suppose you use to the metal nothing but cadmium, zinc, magnesium. At the time, used to the light having the light having the suitable frequency, nothing but wavelength. That is the light here, near ultraviolet light. The near ultraviolet light falling on the metals. From the metal, electron is emitted. That electron passing through the circuit. When the electron passing through the circuit having the electric current. Suppose used to the non-metals. Non-metal are the carbon, phosphorus. At that time, we used to the light is extreme ultraviolet light. The extreme ultraviolet light falling on the non-metals. At that time, the electron is emitted, and the energy of the electron is continuous. That is used to the depending on the metal and used to the light. Then experimentally study the photoelectric effect. What is the operative equivalent watchable photosensitive emitter metal plate, that is the cathode, collector metal plate, that is the anode, voltmeter, ammeter, variable resistance, and battery. This is the watchable. This one cathode, nothing but plate A. This is the anode, nothing but plate B. The plate A, nothing but cathode, is connected to the positive potentials, and anode, nothing but plate B, is connected to the positive potentials. And the anode connect to the positive potential through the galvanometer, or we connect to the voltmeter to the positive potential, and we take in the ammeter. What is the use of the ammeter? The how much electron passing through the circuit, the deflection of the electrons show in the ammeter. That is the use of the ammeter. And then another parameter is resistance. And then we applied the battery, nothing but potential difference, positive and negative. The potential difference negative connected to the plate A, positive potential connected to the plate B. This is the block diagram of the photoelectric effect. When the monochromatic light falling on the electrons, the electron emitted from the cathode and the electron emitted from the cathode. When we applied the positive potential of plate B, the electron is passing through the circuit. How much the electron passing through the circuit? That much of the deflection occurring in the ammeters. We find out the how much current passing through the circuit depending on how much electron emitted from the metal and how much electron passing through the circuit. That is the deflection in the ammeter. Depending on maybe show the how much current passing through the circuit. The work done of the photoelectric. How to work of the photoelectric effect. Monochromatic radiation of suitable frequency fall on the cathodes. The light having the suitable frequency. Nothing but the light have a monochromatic light. Nothing are monochromatic radiations. The monochromatic radiation of the suitable frequency. Nothing but the radiation is must and should monochromatic. What is a monochromatic? The radiation having a particularly a single frequency. Which light or which radiation have a single frequency that is called a monochromatics. The monochromatic radiation having a particular only single frequency and that radiation falling on the cathode. The photoelectron are emitted which get accelerated toward the anode. When the light falling on the cathode, when the light falling on the cathode, the electron is emitted and this electron is reached the anode. This electron flow in the outer circuit result in the photoelectric current. And ammeter show a deflection measuring photoelectric current. What is the monochromatic light falling on the metal? From the metal, electron is emitted. When we apply the potential difference between the plate A and plate B, we increase the positive potential of plate B, increase the current in the circuit. The electron emitted from the metal, depending on the characteristic, that is the four characteristics, how much electron emitted from the metal and how much the having the kinetic energy of the electron depending on the four characteristics. That is the intensity of incident light, applied potential, nothing but potential difference between the anode and cathode, and the frequency of the incident light. And fourth one is different photometals. When the light incident on the metal, the electron emitted the metal, the how much electron emitted from the metal depending on the four characteristics. That fourth characteristic is intensity of incident light, applied potential difference, and frequency of the incident light. And another one is the use of different photometals. We discuss one by one. First of all, the effect of intensity of incident radiations. The anode maintains at definite positive potential with respect to the cathode. The incident radiation of fixed frequency use must ensure the frequency is frequency used. And photoelectric current increase linearly with the intensity of incident light. The first light incident on the metal, the light having the lower intensity, minimum intensity, the current passing through the circuit is minimum. That is indication. And experiment is repeated. Then when next time we use to the intensity of incident light is more intensity, the current passing through the more in the circuit. How much the intensity having the incident light, that much of the current passing through the circuit. That is the clock diagram between intensity and photoelectric current. Incident light having the intensity is increases, photoelectric current also is increases. That is a straight brother graph is the straight lines. I think the photoelectron emitted from sensitive cathode proportionally intensity of incident radiations. Next one is effect of potential difference. Potential difference. The flare, nothing but anode fixed in the incident light have a fixed intensity and the wavelength incident on the cathode. And then we applied the potential difference between the cathode and anode. Suppose increase the positive potential of the anode A, that much of the current is passing through the circuit. Increase the potential difference, current passing through the circuit is increases. How much we applied the potential difference between plate A and plate B, that much of the current passing through the circuit, that much of the current is increases. At a particular potential, the current is maximum. Then we applied the more potential difference between the plate. At the time, the current is not increases. That means the current is saturation. Or current is saturation or maximum. Photoelectric current increase gradually with increasing the positive potential of anode. Become maximum and final at the saturation values. Then we apply the negative potential of the plate. Yes, plate. Potential of the defendant. The negative potential of the plate B increase the negative potential. The photoelectric current is decreases. The negative potential increase of the plate B, the current is gradually decreases. And then finally current is zero at a particular potential. The potential is called a stopping potential. Where the electric current is zero at a particular potential, the potential is called the stopping potential or cut-off potential. What is the cut-off potential? Where light incident is falling on the metal, the positive potential of the plate B increases, the current also increases. At a particular potential, the current is maximum. Whatever may be applied to the potential difference, but current is no increases. That is the maximum of the current, nothing but a saturation current. Whatever may be applied the potential, increase the potential difference, but the current is no increase. That is the current is called a saturation current. After we apply the negative potential at the plate B, the current is decreases. Increase the negative potential, current is gradually decreases. At a particular potential, the current is zero. When the current is zero, that type of the potential is called a stopping potential. The stopping potential depending is a independent of the intensity of the radiations. But the saturation current is directly proportional to the intensity of the incident radiations. How much the incident radiation, how much having the intensity, that much of the saturation current is increases. But stopping potential is no directly proportional to the intensity of incident light or frequency of the incident light. Stopping whatever may be, we apply the intensity or frequency, different intensity, different frequency. But the stopping potential is same. We applied the intensity of incident light, increase I2, 2I, 3I, 4I, 5I. But the all when the negative potential we applied, all current is sharply decreased at a particular potential. At a particular potential, the current is zero. At a particular whatever may be, the experiment is repeated and intensity increases 1, 2, 3, 4. But when we made the negative potentials, the current is gradually sharply decreased at a particular potential. That is called a stopping potential. Nothing but the stopping potential is independent of intensity of the incident radiation or frequency of the incident radiation, whatever may be. Stopping potential is only at a particular single potential value, all saturation current is zero. That is the effect of the potential difference between the plate A and plate B. Third one is effect of frequency of incident radiations. The radiation of different frequency but of the same intensity are taken. Saturation current is the same for the radiation of different frequencies. Different frequency means the radiation having the different frequencies, but the saturation current is same. The value of starting potential is different for the incident radiation of different frequencies. Greater is the frequency of incident radiation, more is the value of the stopping potential. Here, the energy of photoelectric emitted has the Einstein relation according to the Einstein relation E equal to hv. That is a characteristic of the frequency of the incident radiation. Fourth one, what is a used different metals. The plot between the stopping potential and the frequency of the different metals. Suppose we take the alkali metals, what is the potassium, sodium, zinc. The graph we show is the straight line. The same is the straight line is same.